This video is going to be about finding inverse functions. So we'll do 5 problems, get us up and running. And then we get the rest of the semester to practice. All right, so I've got 3 functions that hopefully the operations you're familiar with. And then at the end, we'll do an exponential and a log because you're least familiar with those operations. Neat. Right from the get-go, let's make sure that you understand the language. 5 to the negative 1 is a reciprocal operation. This does not mean this. This is all about the inverse operations of a function, of a calculation. It does not mean 1 over f of x. Okay? So we got to get that right from the get-go. Doesn't mean reciprocal. So many ways to do this. Some folks like to change f of x to y, and then change your y's and x's and solve for y using inverse operations. Some people like to write out the operations of a function and then, just write a calculation based on the inverse. I've kind of landed on that when you put a number in, you got a number out. And the inverse of in out is out in, taking the number that comes out of an equation and working back to what the original equation was. So in other words, for our function 2x minus 3, I could pick a generic number here, let's just say 20. Right? How would I solve for that? Well, I'd add 3 and I'd divide by 2, and I just pick any random number. That is actually the inverse. And we can check it with some other random number. Let's plug in a 5. If we did f of 5, 2 times 5 is 10 minus 3 is 7. Therefore, the inverse of 7 has to come out as a 5. So we plug a 7 in. 7 plus 3 is 10. 10 divided by 2 is 5. So if I wanted to find the inverse of, let's say, 30, all I'd have to do is put 30 here and solve. So I'd add 3 and divide by 2. And then I know that my answer is 33 over 2. And I just show you that for your SATs because they often ask a question like that. So the input of an inverse is the output of the original function. So you try to pause the video now and see if you can do g of x. G of x is equal to 5 halves x minus 7. And we're trying to find g minus 1 of x. All right, so this answer here, this number is the answer to these equations. So if you were solving an equation here, let's say we had 5 halves x minus 7 equals 90. What would you do? Well, you'd bring the 7 over. That gets you a new number, so I'll put it in parentheses. And then you have the choice of multiplying that new number by 5 or dividing by 2. Dividing by 2 would become multiplication on this side. That would undo that operation, and multiplication by 5, division by 5. I'm suggesting that's the inverse of this. Well, let's put a number in that's easy to plug in. G of 4. How many times does 2 go into 4? Twice. 2 times 5 is 10. 10 minus 7 is 3. If this is the correct calculation, then a 3, the output of G, has to be the input. So we better get a 4 out of this when I put a 3 in. So we can do this mentally, right? 3 plus 7 is 10. 10 times 2 is 20. 20 divided by 5 is 4. Sure looks like it's not a formal definition, and I'm not going to give you the formal definition until you get a lot of practice here, and then we can generalize. Okay, but right now, it seems like, from an intuitive standpoint, looks good. So now you're pausing the video and you're trying h of x. I'll write it here. I'm trying to get the old noggin to think. So h of x equals the cube root of x plus 8. And we're looking for the inverse. Well, again, if we were going to solve an equation like the cube root of x plus 8 equals 11, what would be the first operation? I think you'd bring the 8 to the other side. So I think you would take an answer to an equation, and then I think you would subtract the 8, and of course, that's a new number. So I'll put it in parentheses, very important algebra 1 skill. And then what's the inverse of cube rooting? I hope you said cubing. Now, what number would I pick here? Something like 27. H of 27. Let's see what 27 gets us. I don't think it's gonna get us 11. Maybe it will. Oh, it did. Freudian, yeah. Cube root of 27 is 3, and 3 plus 8 is 11. Therefore, the inverse of 11 should get me a 3. Let's put the 11 in. 11 minus 8, 3. 3 cubed. 27. Over here, 27. Got us 11. Over here, 11 gets us 27. I think we're good. Now let's move into new terrain. Because exponential functions are of the variety 2 to the x. So let's put a 3 in here. That gets us 8. Let's multiply 8 by 5. That gets us 40. Let's add 7 to that. And let's make that our new function. Let's call it f of x. 5 times 2 to the x plus 7. And we want the inverse. Okay. So we now know that f of 3 produced 47. Right? 2 to the 3 is 8. 8 times 5 is 40 plus 7, 47. Therefore, our calculation better take 47 and bring it back to the number 3. So generically, how would I solve this equation? I think I'd take away 7. Seems like we're always doing that. That's a new number. I'll put it in parentheses. I think I'm multiplying by 5. I think I better divide by 5. And now we're right back at the thick of it. What is the inverse of 2 to the x? What is the inverse of using an exponent? Finding one. And how do we find exponents? Using logarithms. And what should the base of our log be? I think there's a big clue right here, 2. And so this actually is the quantity, right? And we are going to see if it works. F minus 1 of 47. We're going to see if putting 47 in here comes out as a 3. So 47 minus 7, that's 40. 40 divided by 5, that's 8. What is the exponent you put on top of the 2 to get an 8? That's 3. All right, so that gets us up and running with our conversation. I think those exponents and logs are going to be the ones that are going to take the longest for you to learn. But hopefully the process makes a little sense. And with practice and enough repetition, you are going to try to put that understanding in your pocket. And you'll get a chance in 3 days. All right, see you in class soon.